So this is question 13, paper 1, 2012 higher maths paper, and it concerns quadratic graphs. Now I think what I'm wanting to do, rather than just go straight into the solution of this question, is to give you some background. I mean, part of the purpose of these solutions is to give background so that deeper understanding can come about. So we're going to play around with some parabolas, some graphs. So let's go to a graphing package and do some exploration. So here's a graph, y equals x minus a times x minus b. And we've got a value of 1 for a and a slider that can change that value, and a value of 2 for b and a slider that can change that value. Now looking at this parabola, we can see that it crosses the x-axis at 1 and 2, crosses the y-axis at 2. Now, one of the things you should remember that in a equation, well, the equation we're looking at is x minus 1 times x minus 2. So that's the equation of this graph. And how do we read graphs like this? For instance, if we take x to be 3, then we can calculate a y value. 3 minus 1 is 2, 3 minus 2 is 1, so we get a y value of 2. Now that's represented here by this point. So the height of 2 that appears in this graph will give you the y value for a particular value of x. Now the significance of these 2 points are that the y value is 0. The height of the graph at these points is 0. So for this value, y equals 0. And for this value, y equals 0. And certainly if we put x equals 1 into this formula, this factor here, 1 minus 1 becomes 0. This factor is minus 1, but nevertheless we have a 0 times a negative 1. As soon as we have a 0 in a product of these two things, when we're multiplying these two factors together, if one of them is 0, we will get a value of 0, and the height on the graph will be 0. So this value here, when x is 2, we go into the formula here, 2 minus 2, this factor, x minus 2, becomes 0. Now let me clear that. And let's just put that down. This crossing point corresponds to a factor of x minus 1 being 0. And that appears in the formula for the quadratic. The fact that it crosses here when x is 2 means y equals 0, and the factor x minus 2 is 0. So crossing points on the x-axis correspond to factors in the quadratic expression that gives you the formula for the graph that we're on. Height of 0. One of these factors must be 0. So let's clear that again, and let's start looking at slightly different values for these. Now I've changed the value of b to 3, so we're now looking at y equals x minus 1 times x minus 3. And again, there's that x minus 1 factor, which must be 0 for this to cross the x-axis. And this corresponds to a factor of x minus 3 for this factor to be 0 and the height to be 0. So for this value, x equals 1, we've got 0 times, that'll be minus 2. For this, when x this is the x equals 1 value, and for x equals 3, this will be 2, that's 0. So a factor being 0 corresponds to the place where the graph crosses the x-axis. Let's clear this again. let's change a to 2. So we're now looking at x minus 2 times x minus 3. The graph y equals x minus 2 times x minus 3. That point on the x-axis corresponds to that factor. This point corresponds to that factor. So this value x equals 2 makes that factor 0. This value x equals 3 makes x minus 3 equal to 0. Here's another two values, x minus 2, x minus 5. This corresponds to the factor x minus 2. When x is 2, this factor is 0. This corresponds to the factor x minus 5. When x equals 5, this is 0. The equation of this graph is y equals x minus 2 times x minus 5. We can make things slightly more complicated by making one of these values negative. And if you think about it, what value will make the factor 0? The value is minus 1. So this basically corresponds to a factor x plus 1, or x minus minus 1. X minus minus 1, a is minus 1. So that's a factor of x plus 1. This corresponds to a factor of x minus 2. The equation of this graph is y equals x plus 1 times x minus 2. We could make both of these values negative. This would correspond to a factor of x plus 2. This would correspond, this point here, would correspond to a factor of x plus 1. The equation of this graph would be y equals x plus 2 times x plus 1. Or the way it's written, x minus a, x minus b, where a is minus 1, b is minus 2. So it's always a factor x minus whatever this number is. X minus minus 2, that's x plus 2. X minus minus 1, that's x plus 1. So it's basically always x minus wherever the graph crosses the x-axis to get the factors. I hope that's clear. Now the other thing about these is that if we go back to the graph x minus 1 times x minus 2, x minus 1 times x minus 2, now you'll notice that when x is 0, this factor is minus 1, and this factor becomes minus 2. Product gives you 2. That's where the graph crosses the y-axis. Now, unfortunately, there is not just one graph that passes through x equals 1 and x equals 2, not one parabola. There are other parabolas. And let me show you these by typing in here a k. That produces another slider, and if I change, k is 1 at present, so we do get this graph y equals x minus 1 times x minus 2. However, if I change the value of k, for instance, to 2, notice what happens. Let's slide it back to 1. You'll notice that as the value of k increases from 1, the graph becomes much steeper. Every point, every height in this graph is now being multiplied by 2. So instead of passing through 2, it passes through 4. Obviously, heights of zeros still remain as zeros. There's a point 1, 0 and 2, 0. But this point here, 1.5, halfway between the two values of x, 1 and 2, 1.5 is at minus 0.5. When this factor was back at 1, that point is minus 0.25, but the height is doubled. So this is a scaling factor. All the heights are increasing now by a factor of 4, but you can appreciate looking at this graph changing that there are an infinite number of graphs, that parabolas, that pass through the point 1, 0 and 2, 0. And if I make this scaling factor k negative, then we've now got a concave downwards graph. The graph is not concave upwards. That's concave upwards, that's concave downwards. So the curve is pointing downwards, if you like, concave downwards, concave upwards. But a host of graphs, depending on what this number at the front of the graph is. At present, what you're looking at is not the graph y equals x minus 1 times x minus 2, it's twice that. But still, this corresponds to a factor of x minus 1, and still this corresponds to a factor of x minus 2. The only difference between that and the previous one is the scaling factor. And the previously was just 1, and it's now 2. But the factor being 0, the factors being 0 and corresponding to the x-axis intercepts, that's still true irrespective of what this scaling factor is. So I think that now we should have enough background knowledge to go back to the question and try and tackle it. So here's the question again. Parabola passing through minus 2 and minus 1, crossing the y-axis at 6. Let's get a larger scale picture. So you should now appreciate that that crossing point corresponds to a factor of x plus 2. X minus 2 is the value that makes this factor 0. This point, this crossing point in the x-axis, corresponds to a factor of x plus 1. We could therefore say that this graph has equation x plus 1 times x plus 2, but you know there may be a scaling factor in there that to scale it to this height of 6 when x is 0. That has to work. I mean, if this was a 1, if k, there was no k there, and we put in x equals 0, this factor would be 1, this factor would be 2, product is 2. That is not the height. We would be getting a parabola that scaled to a height of 2. This scales up to a height of 6. So that is not the formula for the parabola. So let's write down what the formula is as best we can. We know that it's x plus 1 times x plus 2 as the two factors, and a scaling factor of k, which we can identify from this. So we'd have to say that when x equals 0, we know y is 6. So we get 6, the scaling factor, times when x is 0, this is 1. When x is 0, this is 2. So we now have 6 being 2 times k. In other words, k is 3. So the scaling factor was 3, which made sense. When k was 1, remember we had a height of 2. This is 3 times that height. So final result is that the formula for this given graph is 3 times x plus 1 times x plus 2. So let's look at the choices. There it is. It's choice D. So choice D.